Let's take a look at this unit in graphs. So the graphs is the square root and the cube root function. So we're going to graph the relationship between a number and its square root, and the relationship between the number and its cube root. So our perfect squares table of values. This is what the function looks like. So we're going to put these numbers and square root them. So when x is minus 4, we put minus 4 into the calculator and square root it, and we get an error. Doesn't work. You put minus 1 in, you also get an error. Finally, 0 works. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3, 4, and 6. All right, so let's take a look at the perfect cubes. So this is our function here. Our function g on x is equal to the cube root of x. So we put minus 27 in and we cube root it and we get an answer. We get minus 3. You put minus 8 in, you get minus 2. You put minus 1 in, you get minus 1. Then you get 0, 1, 2, and 3. These are the values. Now, when I graph them, I'm going to use different colors. I'm going to use red for the first one and blue for the second one. All right, so, holy smokes, did I do that? Urkel, did I do that? The square root of 25 is not 6. It is most definitely not. It is definitely 5. All right, so our x's go along the horizontal. We need to go up to 27. And looking at my little guys here, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can probably just do 1. So 1, 2, 3, 4, 5. Remember, you don't need to mark every single one. 2, 3, 4, 5. That's 10. 2, 3. That's 15. 2, 3, 4. That's 20. And it doesn't quite fit. We're not going to get to 27, but we'll get enough points on there for it to make sense. And we'll go the other way. 1, 2, 3, 4, 5, negative 5. 1, 2, 3, 4, 5, negative 10. 2, 3, 4, 5, negative 15. 2, 3, 4, 5, negative 20. Again. Now, our x values are going up to 25 and down to like minus 27. Our y values don't get up very high. So we're going to stretch them out a little bit to give us some more space on our y. So I'm going to mark 1, 2, 3, 4, 5. Right there will be 5. 2, 3, 4, 5, 10. Going down, 1, 2, 3, 4, negative 5, 3, 4, negative 10. All right, let's graph the square root function. We're going to do that in red. It's going to go to 0, 0. At 1, it's also, at 1, it's 1. So it goes there. At 4, it's 2. That's right there. At 9, it's 3. 9, it's 3. That's right there. And at 16, it's 4. 16, it is 4 right there. And it's going to continue on in this path. We don't have to graph them all, but it is going to keep going on in that direction. That is our square root function. Now let's graph the cube root function. We're not going to get all the way out to minus 27, but we will get to minus 8. So at minus 8 is minus 2 right there. Then at minus 1, it's minus 1 right there. Then it's 0. Then at 1, oh, I did an error on this point right here. Should be there. Then it'll also be there. And then at 8, it is at 2. So this graph is going to look kind of this S graph like this. So there we have our square root function and our cube root function. That's the blue function. And here's the red function. All right, so let's take a look at these quick questions. What happens when you try to find the square root of a negative number? You can't do it. It gives you an error. Where do the graphs have the same values? Well, they both go through the point 0, 0, and they both go through the point 1, 1. Those are the 2 points where they have the same value. Which graph is going up faster? Well, that is the red graph is going up faster. So the square root function rises faster. All right, so you should be able to graph any 2 simple mathematical function given a table of values. If you have any questions, please put them in the comments below or contact me. And thank you for watching.